So today what we're going to do is we're going to take a look at an excess limiting question combined with a percentage yield question. Alright, so for pure chem students and combined chem students, you need to know how to solve excess limiting questions, and then for pure chem students, you must know how to solve percentage yield questions. Alright, now the most common question I get for excess limiting is, how do I spot an excess limiting question? The answer actually lies in the amount of data that's given. So here we see we're given 13.7 grams of manganese oxide, and we're also given 25.3 grams of hydrochloric acid. Now if you recall, the first step to solve any mole calculation question is to find the number of moles. But the question here is, since we're given two values, or two sets of data, which do we use? And the answer is both. So we start by finding number of moles of manganese oxide and number of moles of hydrochloric acid. So number of moles of manganese oxide, MnO4, is mass in grams over AR, or MR rather, so 55 and 16 times 2. And this gets you something like 0.11512 mole. Now what you will then do next is to find number of moles of hydrochloric acid. Number of moles, hydrochloric acid, mass in grams, 25.3 over 36.5, which gives us something like 0.6935 moles. Now the next thing you want to do is identify which is excess and limiting. And to do that, we first of all look at the mole ratio. So MnO2 to hydrochloric acid is given in the mole ratio of 1:4. Alright, so now this part is a bit tricky. So first of all, we are given 0.1152 moles of MnO4, and we are also given, alright, 0.6935 moles of hydrochloric acid. Now you just choose one value, and I always typically just choose the one that's in front, which is MnO4. Alright, so I'm going to go with given, so given 0.11512 mole of MnO2, alright, we multiply that by 4, and we find that 0.46048 mole of HCl is required. Now we then compare what is required to what is given. Alright, and because we are given a lot more than required, we can then conclude HCl is excess and MnO2 is limiting. Okay, so once we do this, all we need to do now is to find the mass of manganese chloride. We go back to the three-step method, and step 2 is to use the number of moles of limiting now. Alright, so mole of limiting MnO2 to what we want to find, which is MnCl2. And the mole ratio, based on the balanced chemical equation, is 1:1. And so we have 1:1, and 0.1152 is to 0.11512. Sorry, there's a 1 there. Okay, mole. And finally, to find the unknown, we take mass is equals to mole times Mr. Alright, so 0.11512 multiplied by Mr. Manganese 55, chlorine is 35.5 times 2, so that's 71. And we get something like 14.5 grams. So that gives us the first part of the question. Alright, find the expected mass, or find the theoretical mass, or find the calculated mass of manganese chloride. Now moving on, the question here says this. Okay, sorry, there's a typo there, right? It's 10.4. Alright, now if only 10.4 grams of manganese chloride was formed, so we expect to get 14.5 grams, and then we carry out the experiment and we get only 10.4 grams. So the percentage yield is what we obtain via the experiment, or in real life, 10.4, over what we're supposed to get, theoretical, 14.5, multiplied by 100%. And that gives us 71.7%, rounded off to 3 significant figures. So I hope you found that useful. Thank you for watching.